This is Bob Capetto from the College of the Florida Keys, and this lesson is on simplifying radicals. So if we start with something like the square root of 9, we ask ourselves what number times itself 2 times is 9, and the answer, of course, is 3. But let's build a process for that. So we will say square root of 9 is the square root of 3 times 3. A square root needs a pair of identical factors. So we circle the pair of identical factors. It comes out of the square root sign. There is nothing left under the square root, and our answer is 3. Let's go and look at the square root of 12. Now, I don't have an obvious answer. What number times itself equals 12? But what I can do is I can factor 12. 12 is 6 times 2. 6 is 3 times 2. So 12 is 3 times 2 times 2. So that will be our process for simplifying the radical. It will be the square root of 3 times 2 times 2. Here's my pair. A square root requires us to take out a pair, so we get 2. 3 is still left under the square root, so that my answer there is 2 times the square root of 3. Now we can also go to cube roots. If I ask for the cube root of 24, I need to factor 24 as far as I can and then look for triples. A cube root needs triples, a square root needs pairs, a fourth root needs quadruples. That in essence is our process. So let's factor 24. 24 is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. So completely factoring 24, we get the cube root of 2 times 2 times 2 times 3. Now I look for triples. I have a triple right here. 2, 2, 2 comes out of the cube root, and we get 2 times the cube root of 3 for our cube root of 24. So that in general is our process for simplifying square roots and cube roots. Negative signs, of course, make things a little bit more interesting. If I ask for opposite the square root of 49, this means -1 times the square root of 49. And we know that 49 is 7 times 7. So this means -1 times the square root of 7 times 7. I need a pair. The pair comes out. So we get -1 times the square root of 7 times 7 is 7, and my answer is -7. But if instead I ask for the square root of -25, this is a problem. What number times itself is -25? Well, a negative number times a negative number is positive. A positive number times a positive number is positive. There is no number multiplied by itself that will give -25, at least no real number. So that's what we have to say, no real number. But if I go to a cube root of a negative number, we'll have one. For example, what is the cube root of -27? Well, I can factor -27. How can I factor it? Well, I think the most sensible way to factor it in light of the cube root is to recognize -27 is -3 times -3 times -3. -3 times -3 is 9. 9 times -3 is -27. I look for a triple. We have a triple here. That can come out, and my answer is simply going to be -3. So taking a square root of a negative number is a problem. Taking a cube root of a negative number is not a problem. But if the negative is out in front of the radical, it's just multiplying the final answer by -1 to go ahead and get our solution. Now, when does this get interesting? What if we have a situation like this? If I have the square root of 48 x squared y cubed. We want to assume all variables are positive. Be careful with this. Recall, in general, the square root of a squared is absolute value of a. But if a is positive, the square root of a squared equals a. So we're going to assume all variables are positive. So we don't need to concern ourselves with that. But we still need to go ahead and do our division here. So we have our problem. We want to go ahead and divide to see how this behaves. Divide out, do our factoring. So 48 is 6 times 8. 6 is 2 times 3. 8 is 4 times 2. 2 times 3. 4 is 2 times 2. And another 2. So we have 2, 2, 2, 2, 3. Or 16 times 3 if you see that. So anyway, we're going to go ahead and write this out. We started with 48 x squared y cubed. Now I factored 48. 48 is 2, 2, 2, 2, 3. X squared is x, x. Y cubed is y, y, y. Now to simplify this radical, we need pairs. We're going to examine pairs. I have a pair of 2's. That comes out. I have a pair of 2's. That comes out. I have a pair of x's. That comes out as long as it's positive. I have a pair of y's. That comes out. What is left in the radical is 3y. Everything else has been extracted. So I get 2 times 2, or 4xy, times the square root of 3y is how we would simplify that. Square root. We could also simplify a cube root. Again, our process is going to require us to do what? Our process is going to require us to factor and then look for triples. So if I have the following. If I have the cube root of 96, I wrote 8th root. Let's try that again. Let's go with the cube root of 96. X to the 8th, y to the 7th. So to do this, I need to factor everything and I need to circle triples. So I should be able to do that. Our process is going to be 96, maybe is 48 times 2. We just did 48, but I can do it again. 6 times 8 times 2. 6 is 2 times 3. 8 is 4 times 2 times 2. 2 times 3, 4 is 2 times 2, and then we have 2, 2 again. So I get 2, 2, 2, 2, 2, 5 2's. 2, 2, 3, 4, 5. 2, 4, 8, 16, 32 times 3 is 96. So then we're going to go ahead and expand this. So I have the cube root of 96, x to the 8th, y to the 7th. So I've just done this expansion, this factoring. So I get the cube root of 2 times 2 times 2 times 2 times 2 times 3. 1, 2, 3, 4, 5 2's, 1, 2, 3, 4, 5 2's times 3. X to the 8th, 1, 2, 3, 4, 5, 6, 7, 8. Y to the 7th, 1, 2, 3, 4, 5, 6, 7. And we're looking at a cube root, so we need to find triples. Where do I find triples? I find triples of 2. So 2 comes out of the cube root times. Double 2 and a single 3, not enough to come out, but a triple x. An x comes out. Another x, x, x comes out. Now I have 2 x's left, not enough to come out. Now we look at y's. Y, y, y. A y comes out. Y, y, y. A y comes out. Who is left under the cube root symbol? What do we have? We have cube root 2, 2, 3, x, x, y. So let's simplify our answer, and we get 2, x, x is x squared, y, y is y squared. What's left? Cube root of what? 2 times 2 is 4 times 3 is 12, xx, x squared y. So that's our general process for simplifying square roots, cube roots, etc. Of course, higher roots are done exactly the same way. If I ask for the cube root, or excuse me, the fifth root of, let's say, x to the 11th, y to the 17th. The process is still the same. I could write the fifth root, I need 11 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then I need 17 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And I need to circle 5 of them now. 1, 2, 3, 4, 5 is there. 1, 2, 3, 4, 5 is there. So x comes out, and then another x comes out, and that last x, the 11th x, is left. Now I've got y to the 17th, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Y comes out. And who's left under the fifth root of x, y, y? So x squared, y cubed, to the fifth root of x, y squared is our final answer there. So you can see the process is indeed the same. Now, when we multiply radicals, you essentially combine them. So if I want to do the square root of 6 times the square root of 18. Well, 6 is 2 times 3. 18 is 9 times 2, or 3 times 3 times 2. But what I can do when I multiply radicals, I can put them in a single radical. So that's 2 times 3 times 3 times 3 times 2. So 2 2's and 3 3's. 2 times 2 times 3 times 3 times 3. And then we're looking for pairs. Circle the pair of 2's, 2 comes out. Circle the pair of 3's, the 3 comes out. What's left under the radical? Square root of 3, what's my answer? My answer is 6 times the square root of 3. Let's do one with cube roots. If I have the cube root of 4 x squared y squared times the cube root of 6 xy squared, I have the same radical. The same radical enables me to write them together. But let's factor first. Cube root 4 is 2 times 2. X squared is xx. Y squared is yy. Cube root of 3, 6 is 2 times 3. X is x. Y squared is yy. I have the same index. They're both cube roots, so I can write it as a single cube root now. So we get cube root of 2 times 2 times x, x, y, y times 2 times 3 times x, y, y. How many 2's do I have? Let's put them all together now. 2's, 1, 2, 3 2's. How many 3's? Just 1. How many x's? 1, 2, 3 x's. How many y's? 1, 2, 3, 4 y's. And we're looking to circle triples, so I have 3 2's. A 2 comes out, I have 3 x's. An x comes out, I have 3 y's. A y comes out, and I'm left with the cube root of 3y. 3 is still under the radical, y is still under the radical, and that looks like that is my final answer. But the same process also works with division. So let's take a look at a couple of those. if I have the square root of 72 over the square root of 4, what I can do is I can write it as a single square root. So I can say the square root of 72 over 4, which I could just factor the top and the bottom. That's perfectly acceptable. 72 is 9 times 8. So 9 is 3 times 3. 8 is 2 times 2 times 2. 4 is 2 times 2. So you'll notice the 2's cancel. And I wind up with the square root of 3 times 3 times 1 times 1 times 2. So over 1. So the square root upstairs of 3 times 3 times 2. Downstairs, I just have the square root of 1, which is 1. But upstairs, it's a square root, so I'm looking for pairs. I can pull the 3 out. So I get 3 times the square root of 2 over 1, which equals what? Which equals 3 times the square root of 2. The one last thing I'm going to say regarding these things is if you have different indexes, you have to be careful. So if I want to do the cube root of x times the 5th root of x squared, I cannot just put them together in one single radical. What I have to do here is I have to appeal to the fractional exponents. So this is x to the 1 cube root, so that's x to the 1/3 times x squared 5th root, that would be x to the 2/5. If this happens, you have to go ahead and do x to the 1/3 plus 2/5. 5 and 6 is 11/15, so that's x to the 11/15, which would be the 15th root of x to the 11th. So in the event the indexes are different, it's not quite as simple as just putting them together. Let me go ahead and do one of those with division, so that if I have the 5th root of x to the 7th divided by the cube root of x to the 4th, I would probably simply do it this way. Now you could simplify this, but I'm going to make it x to the 7/5 divided by x to the 4/3, which would be x to the 7/5 minus 4/3. If you have the same base, you can subtract the exponents. X to the 7/5 minus 4/3. 21 minus 20 is 1, x to the 1/15. And that, of course, just equals the 15th root of x to the 1st. Would be one way for us to simplify that a little bit. Okay, that will conclude this lesson.